The three criteria that we had was size, 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 similarity, size equals size. Unfortunately, they're not our problem. All right, so Clarissa is one of the surveyors hired to help determine land boundaries. She needs to find the distance across the property relocate they're seen as two triangles. She has a big triangle and a little triangle. From this triangle, she knows the distance between 5 meters. She knows that the measure of angle for each is 55 degrees. She knows the measure of angle of each is 61 degrees, and the measure of angle is 64 degrees. She also knows the measurement is 65 degrees, and the measurement is 65 degrees. So overall, she has about. So what I would like for you to do is make some problem with similarity criteria for that you look at the time discuss with the person what you see, what information you know, what is it right now. Maybe not right now. have BC is 65 and AC is 85, right? But we don't have any other sides. We have this one, 65. So if we knew what the scale factor was, we could determine if that was proportional. So with this one, because we have two angles, that's all we need. We don't have any other sides besides side angle side. Why are they not? We justified it with our explanation. Alright, so the triangles are similar, so the corresponding sides are proportional. We can solve the proportions to find the distance of the AC. So we filled in this, right? We had DC was 65, and it matches up to what? 85. And we filled it in up here. That shows 85. And then AB matches up to which side from the proportion? CD, which is how long? So can we solve that proportion plus AB? Yes. Because we show that by angle and similarity, everything triangles are proportional, and we know that all of those ratios are going to reduce to the same amount. We're using the same scale factor to get the sideline. So what do we get for AC? What is the length of an AC? The effort becomes 71.92. And then what are our units that go on to this? Meters. So we know the distance across the ravine is 71.92 meters. So what we did here was because the forest did not take a tape measure and stretch it across the that would be a direct object. Because she measured it using math, that's called indirect measurement. So indirect measurement is measured that it cannot be measured directly, such as the height of a tree or the distance across a lake or the triangle similarity is often used to make so then if you were going to survey indirect measurement, so what this does is is inside triangle CAC. So here we want to show that the two triangles are similar to each other, and we want to find the length of yes. So we know she measured, she directly measured the length of the and the length of the so we can find what the this way. So what is and we can do the same thing on the other side. We know 80 is 84, and if we know that 18 is 36, so then that means that it is how much? So we can set up our proportions. Substituting in numbers, now what do we know about triangles? Not like so if we can show that these sides are, if we can show that these are similar, that this is a consistent, then what does that tell us? They're similar. So let's do these. When we multiply this out, it multiplies out so that 4704 equals 4,704. So are these two triangles? Yes, they are. Also, reflect the property of side equals side. But that's not also needing to write all the proportions by the length of AB. So again, we're going to use our proportion substituting in the numbers and now know everything every time. So substituting the numbers so the width of the rock formation is 4.5. That is 175. And we're actually applying. So let's practice. Let's try letter A. So I would like for you to work this out, compare your answers, and so present next to you, and then we'll discuss it. So let's determine similarity. So looking at similarity, how are these triangles similar? Are they similar? We know that, let's set up, we have triangle ECD. It isn't similar to triangle AC. Question mark. So what are our angles that went from B and A? Those are congruent, right? Those are Now comes the algebra. So now that we know these we set up a proportion, right? Since they're similar, what do we know about our signs? They're increasing and decreasing at the same rate. So what does our proportion look like? So we have A over CD. And what's the other side look like? Our goal is to find CD, which is this right here. Over these. So we have big triangle on top, little triangle on the bottom, right? Is that the only way we can set up the proportion? No, you could have put in size on one side. The whole the big is a proportion of these white things together. This is what organization is defining for. Alright, so what do we know about AE? What's the length of AE? 35, and the length of BE? 20. Alright, we've got a problem because I don't know the length of AE and I don't know the length of BE. So what So what do we do to get the length of AE? That would work if I did the whole if I did this, if I did the whole thing. So I asked, what do we do to get that AE? And it's just adding them together. Adding them together, right? So what's that called when we add segments together? Segment addition, right? What do we do if we don't know something? Yes, but we can substitute. What do we want to put in? What do we want to set like B, C? What can we call it? What else do we call it? We can call it X, right? Do we have to call it X? We can call it variable X1, right? You want to call it